we were graphing this system of equations and ran out of time and also kind of ran out of board space. So let's take another look. We have y equals 4x plus 2, y equals negative 4x plus 1. For this equation, y-intercept occurs when x equals 0. So y equals 4 times 0 plus 2. So y equals 2. The y-intercept of this equation, x equals 0. So in this case, y is going to be 1 because if x is 0, y is 1. We can begin the graph. With the point 2, 0, corresponding to the first function. And I said 2, 0, 0, 2. Never will get over the tendency to reverse it. And then y-intercept here at y equals 1 when x equals 0. So at x equals 0, y equals 1. We have this point. The slope of this graph is 4. Now we could find the x-intercept. Well, if we let y equal 0 and solve, we get x equals 1/2. It's kind of difficult to locate x equals 1/2 on the x-axis, or even the x equals negative 1/4, which we would have if we found the x-intercept of the second. You should be able to find those x-intercepts. Just let y equals 0 and solve for x. And a lot of times that's the easiest way to draw the graph. In this case, it's not very practical because there's a lot of uncertainty. Your y and x intercepts for both of these would be a little too close together. So I'm going to say that what I would tend to do in this case is go to the on x equals 1. So that means that from this point to get to the x equals 1 point of the graph, well, the slope is the slope is 4. Here's the coefficient of x in the y equals mx plus b. Or y equals 4x plus 2. Slope is obviously 4. And the slope of the second line is negative 4. Okay, so to get a slope of 4 in the first line, we start at the y-intercept, we move over 1 unit, and then we move up 4 units. And if that's 2, then 4 would be about there. So we have to move up pretty far. So we move up 4 units. And we get a point on the graph, which is up there in the middle of my equation. That's very well planned. And then we draw a straight line through these points. And here is the graph of y equals 4x plus 2. And if we want a slope of negative 4, starting from the y-intercept, which is at 0, 1 for the second equation, we move over 1 unit and down 4 units. And here's our point. So this point and this point are on this graph. So we draw a straight line. Oh boy, that's not very good. X equals 1 label down here a little bit. Pretty badly drawn line. I didn't hit the y-intercept very well. It's so bad that even though it's going to slop up the picture, I'm going to kind of erase it. and replace it with a better version. Yeah, now that's a little too far on the other side. In any case, these lines cross somewhere just to the left of the y-axis for a fairly small value of x. Now this line isn't quite right, should be over a little further, so this is going to not be a very good estimate. But we estimate the intersection to be, I would say, -1/2, and about, it's between 1 and 2. If I'd have drawn the lines a little better, I think maybe the intersection point would have been 3/2. Matter of fact, I'm pretty sure it would be. Okay, well, that's not really an intersection. I fudged it. If I went with the number here, my actual intercept would probably be like -0.6, 1.2. Okay. So I'm actually going to back off of this one. And say, honest estimate, taking my badly drawn line, would be -0.6, 1.2. That's an estimate. We can plug these numbers in, check the estimate. Okay, let x equal -0.6, let y equal 1.2. You get y equals 4x plus 2. If we plug 1.2 in for y, we get -1.2 equals -0.4. It's not good. If we plug the same numbers into the second equation, you can do this yourself. A -0.6 here times -4 give me a 2.4. Add that to 1, we get 3.4. And we sure aren't going to get y equals 1.2. Okay. So the graph is pretty bad. Let's get an accurate solution. One way to solve it, y equals 4x plus 2, and y equals -4x plus 1. If y equals this and y equals this, then this equals this, and 4x plus 2 would equal -4x plus 1. Well, we would add 4x to both sides and subtract 2 from both sides. We would get 8x equals -1, x equals -1/8, which is -0.125, which is much different than this -0.6 estimate that I've got here. If you draw a more accurate graph, you can probably get a better estimate. Then if x is -1.25, it follows that y equals 4 times x, which is 4 times -1/8, plus 2, which equals 4 times -1/8 is -1/2, plus 2, which is 3/2. Now you notice I had a 3/2 up here earlier because I knew by the symmetry that the intersection would be halfway between y equals 1 and y equals 2, which is what 3/2 is. Okay. The accurate intersection is -1/8, 3/2, which would be -0.125. (1.5) if you want to do it in decimal form. I prefer we work with fractions, but I'm not going to belabor that today. I've been doing it all semester. If we plug these numbers into the first equation, 4 times -1.25 is -0.5. So we get -0.5 plus 2, which is 1.5. If we plug -0.125 into this equation, -4 times -1.5 is 0.5. Add that to 1, we get 1.5 again. So you can do that, and you should be able to do it with fractions as well. So we check these. In the original equations. And I leave room here where we could check them, but I'd have to write small, and we're not going to actually do that. Still, I want to emphasize when you're doing practice problems for the exam, you want to write out the details, because that way you retain the details. Okay? It's more than just getting the answer right, although that's really the first goal. But the other goal is to get the answer right in such a way that you're likely to get it right the next time you see a problem of this nature, and that you internalize some of these ideas and concepts and procedures. Okay. Well, that completes that problem. Now, I'm going to look down here. And I just can't remember all my signs, are really my numbers. And multiplying x squared plus 5x plus 3 times 2x minus 3. And that would be problem number 7. Well, this is easy enough if you understand the distributive law, and everybody's in class today understood it, but let's just go over it for anybody who might still be confused. I'm going to multiply from left to right and say, okay, this by the distributive law is x squared times 2x minus 3 plus 5x times 2x minus 3 plus 3 times 2x minus 3. All we're saying is that x squared multiplies this, and then 5x multiplies this, and then 3 multiplies this. That's the essence of the distributive law. If we multiply these out, x squared times 2x gives me 2. Well, yeah, no, I'm debating. I'm going to write this out in detail. It's x squared times 2x minus x squared times -3 plus 5x times 2x minus 5x times 3. And naturally, I run out of room here. 3 times 2x minus 3 times 3. So again, x squared times 2x goes here. X squared times -3 goes here. 5x times 2x here, 5x times -3 here. And 5x times -3 is the same as -5x times 3, so write that out. 3 times 2x is here, minus 3 times 3 is here. Okay. Now we just expand these. We get 2x cubed plus 3x squared. Negative times a negative is a positive. 3 times x squared. 5x times 2x is 10x squared. Minus 5x times 3 is -15x. 3 times 2x is plus 6x. Minus 3 times 3 is -9. Now we can add the x squared terms and the x terms. We only have one x cubed term, so it's going to be by itself. We add the like terms. Okay. In other words, whatever x is, x squared is going to have the same value here as it has here. So we can add 3 of them to 10 of them. And we get 13 of them. We can't add anything times x squared to x cubed because as x changes values, x cubed and x squared don't change in the same way. Okay, well, -15x and 6x is -9x, and then we have -9. Now, if I've done this right, I should be able to pick any number out of a hat and plug it into this expression, and plug the same number into this expression, and show that they're the same. But I don't want to use x equals 1. So I'm going to check for x equals 2. Now, just show you, if I check for x equals 1, I'm just going to get 2 plus 13 minus 9 minus 9. 2 and 13 is 15, minus 9 minus 9 is minus 18, so we get -3. If x equals 1, this doesn't give me the same answer. I get a 1 here and a 5 here and a 3 here, which adds up to 9. And I would multiply that by -1, and I'll get -9. Well, one of these signs is messed up, I can tell that. Now, we could check for x equals 2. And we would find that it doesn't match. I just checked for x equals 1. So I'm going to say we check for x equals 1 just to write it out. Got -3 a minute ago. The reason I got -3 is because it is -3. Okay. If I write this expression out, this gives me 2 squared plus 5 times 2. Oh, sorry, we're doing 1. So we plug in 1 for every x value. We get 1 plus 5 plus 3, which is 8 times -1. Which is -8, not -3. So where did I go wrong? Let's see. X squared times 2x is 2x cubed. That's got to be right. X squared times -3. I wrote plus 3x squared. I had too many negatives in this thing. Okay. So it should be plus x squared times -3, which gives me -3x squared here. So I was very careless when I wrote this down. I saw the negative here, so I put the negative in front here. And then I forgot that I'd already used the negative and wrote it also in front of the 3. Okay, then 5x times 2x is 10x squared. 5 times negative 3 is negative 15. So 5x times negative 3 is negative 15x. And 3 times negative 3 is negative 9. Now this gives me 7x squared. Okay. And now I seem to have a problem because if it's 7x squared, be 7 times 1 squared, which would give me 7 instead of 13, which gives me 9 minus 9 minus 9, which gives me negative 9. And I got negative 8 here. Well, I just didn't do my arithmetic right here. I did it too quickly. 1 and 5 is 6, and 3 makes 9. So that should be 9 times negative 1. And there's negative 9. So it's a good thing I checked. Now I could check for another number. 1 is not always the best number to check for, but we'll just leave it at this. I would also check for 2. Now I'll do it in my head so I can be sure that it's wrong. 2 cubed is 8, that makes 16. That's 28, so that's 44. And then it's minus 18. 44 minus 18 is 26. Okay. And it'd be 8 and 10 and 3. It's 16. 44 minus 44 minus 18. 6. I get 16. So I really probably would want to write that out. Let's look at this one again. That's going to be 16. That's going to be 28, gives me 44. Oh, 9x would be negative 18 and minus 9, which is negative 27. And 44 minus 27 is 17. I get 17 here instead of 16. I probably do. I get 4 and 10 is 14 and 3 is 17. And now I get 17 and 17. Now I'm doing this quickly in my head just because you don't want to sit here and watch me do all the arithmetic. I certainly don't want to watch me do it in my head, but that's quick. Okay. I'm claiming if you plug in 2, you get 17 for this expression and you get 17 for this expression. Okay. And that's the way you can be relatively certain that this has been done correctly. Okay. Now, we want to factor. X squared plus x minus 6 is number 8 out of 9. Okay. Well, we can do it by trial and error. We could use x minus 2 and x plus 3 because negative 2 and 3 give us negative 6. Negative 2 times 3 gives us negative 6. And the negative 2 times x and the plus 3 times x gives us plus x. Excuse me, x squared plus x minus 6. Well, I hit it on my first try. But there's only one other reasonable thing we could have tried, which would have been x plus 3, x minus 3, and x plus 2, which would have given us a negative x. So you can see that one rather quickly. And people are using a trick that involves putting 4 numbers in a grid that looks like this. And you can do that. I kind of prefer that you just concentrate on the distributive law and see how it works out. But if you've got a lot of factors, this thing could be a lot of help. So I'm not going to do that. Last problem was solve 2, -6, -2. Okay, there are 2 ways we could solve this. We could try to factor it. That would be kind of a mess. But maybe since everything is divisible by 2, it's possible it could work out, but I can tell pretty easily that it won't work out with whole numbers. So the equation is of the form ax squared plus bx plus c equals 0. So we identify a, b, and c and use the quadratic formula. With a, the coefficient of x squared is 2. B, the coefficient of x is -6. And C, the number without an x on it is -2. So x equals, I'll write out the formula, which you need to know. Although there might be a hint on the exam, I wouldn't count on it. Okay, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. B is -6, and negative b will be the negative of -6. Then we have the square root of b squared. That'll be the square of -6 minus 4 times a, which is 2, times c, which is -2. And then it's over 2a. A is 2, so it's 2 times 2. Okay. So let's write it out a little more clearly here. It's negative of -6 plus or minus square root of -6 squared minus 4 times 2 times -3, all divided by 2 times 2. What are the numbers? Negative of -6 is 6. Square -6, we get 36. 4 times 2 is 8, times 3 is 24. And we have a negative and a negative, so that's plus 24 divided by 4. 36 and 24 is 60. We have 6 plus or minus the square root of 60 over 4, which we could write as 6 over 4 plus or minus the square root of 60 over 4. And we can approximate that as it is. Now, if we want to be really elegant about it, 6/4 reduces down to 3/2. 60 is 4 times 15. Why do I do that? Because of this 4? No, it's just because 4 is a perfect square and it divides into 60. Leaves me 15, and there are no perfect squares that divide 15. I'm going to go ahead and write this down as okay, the square root of 4 times 15 is the square root of 4 times the square root of 15. We're dividing by 4. You don't want to divide this 4 into this 4 because this 4 has got a square root. This 4 is within a square root. So we can write the square root of 4 as 2. And there's our answer. You say x is 3/2 plus, well, if we divide the 2 into the 4, we get 2. 2 over 4 is 1 over 2. So we get this form. So the solution would be 3 plus the square root of 15 over 2. Remember that 2 is not under the radical sign because it came from this, which is not under the radical sign. Or x is 3/2 minus square root of 15 over 2. Solution set becomes, or can be expressed as the set consisting of 3/2 plus the square root of 15 over 2 and 3/2 minus square root of 15 over 2. Now, the application of the quadratic formula is very straightforward. You just put the numbers in and do everything right. If you end up with something that you can't take the square root of, like 60, you express 60 as a product of the biggest possible square and whatever you get when you divide that number into 60. Okay, whatever. And then you separate it out into the square root of a perfect square and the square root of whatever's left and simplify it. So that can get a little involved, but open math gives you really good guidance on that. And people did well on that assignment on the homework, assignment with quadratic formula. So I'm pretty sure people are in pretty good shape with this. If I was grading a problem like this, I'd give you a few points out of 10 for recognizing that you have the quadratic equation. A couple more points for knowing that you're going to use the quadratic formula and plugging and identifying the numbers, and then the rest of it for simplifying whatever you get here, which can be a little complicated. If you get down to this point, or at least to this point, you've got most of the credit. If you mess up something between here and here, you could still get 8 out of 10 because there's a lot involved with this problem. You have to recognize that it's quadratic. You have to know the formula. You have to be able to identify A, B, and C. Then you have to plug it in correctly and simplify what you get down to at least this point, and then complete the problem. Okay, there are about 5 things you got to do. All right, well, that's it for these examples. The other thing is check. And to check this, squaring this and squaring this, multiplying by 2 and all that gets a little bit involved. To check, Use a calculator to approximate your solutions. 3/2 plus the square root of 15 over 2 is approximately equal to 3/2 plus, we'll say 3.9. Calculator give you a more precise value for that. It'd be 3.88 or something like that. So you get something like 3.45. You can plug that back into the equation and see if you get 0. Well, let's see, 2 times 3.45. And I'm doing this in my head, so I'm not going to be as accurate. That's squared times 6 times 3.45 minus 2 equals 0. Question mark, does that equal 0? Well, it's not going to be exactly 0 because there are a lot more decimal places in the square root of 15 than I've allowed for. If you square 3.45, you get about 11. So this is about 22. 6 times 3 is 18, and half of 6 is 9. So I'm going to say that's maybe negative 21 minus 2. Does that equal 0? Well, when you add all this up, you get negative 1 equals 0. That's pretty close. So that's not an absolute check, but it's pretty good confirmation. And then you could do three-halves minus the square root of 15 over 2. Well, you use the same numbers, but you subtract this one, giving you 0.9 over 2. That's about 0.45. Two times 0.45 squared minus 6 times 0.45. Where's my equation? Minus 6? No, minus 2. Does that equal 0? 0.45 squared is about 0.2. You multiply that by 2, you get about 0.4. 6 times 0.45 is like 0.27, 2.7. And something's wrong. I should have been negative 0.45. So I'd have a negative in this one. The negative in this one would still give me 0.4 to be squared, but that would make this term positive. And when I add these up, I get 3.1 minus 2. That's a little further off than I would have expected. I must have done something wrong up here. But anyhow, we get like 1.1 equals 0. For a small number like 0.45, I should have been a little closer to 0. But still, it's probably okay. My 3.9, oh, you know, minus 3.9, that's going to be negative 0.45. This number should have been a little smaller, but not much. Anyhow, I'm not gonna belabor it. You can plug the accurate numbers in and see what you get. Should come out closer. But there it is. Okay. Now my main message is work problems, refresh your memory, and check everything so you know whether you're doing them right or not. Test will be in the testing center next week. Test needs to be taken in learning during testing center hours before closing, which I believe is next Friday at 5 o'clock. You can check the testing center hours. I'm not going to try to tell you what they are because I can make a mistake. Just check the website. Or call the college and ask for the testing center and ask them. 276-739-2400. Get you the switchboard. You can easily get the testing center. Okay. Please let me know if you have questions. If you have problems you'd like me to look at, send me copies or bring them. And wish you good luck on the test and on all your exams, and a great Christmas holiday. Okay. So it's been good having everybody in class, even though a lot of people didn't make it to class the last couple of weeks. And life gets in your way, that happens. Okay. Very good. Hope everybody does well.